It soared to the skies, promising a future where Mars isn't a dream but a destination, yet ended in a fiery spectacle that left the world in awe. What really happened on SpaceX's 7th Starship launch attempt? On a crisp morning at SpaceX's Boca Chica launch site, all eyes were on the towering Starship 5-2, a gleaming testament to human ambition. Dubbed the next giant leap for mankind, this version of Starship was more than just an upgrade. It was a revolution. Taller, sleeker, and smarter, it carried the hopes of a generation dreaming of interplanetary exploration. It was not another test flight, but the 7th in a series that had already pushed the boundaries of rocket engineering. Starship 5-2 featured a redesigned forward flap system, state-of-the-art avionics, and propulsion upgrades, including the mighty Raptor engines. These innovations aim to make space travel more efficient, reliable, and ultimately reusable. But the stakes were high. After a string of mixed successes and setbacks, SpaceX needed this flight to demonstrate progress and validate its ambitious goals. T-10 seconds. The ground shook as the countdown reverberated across the Gulf of Mexico. At 8 a.m. sharp, engines roared into life in perfect cacophony. 33 Raptor engines lit up simultaneously, sending Starship 5-2 on its way through a column of fire and smoke. Liftoff was textbook perfect. It was a show that observers and engineers alike followed with awe as the rocket sliced through the atmosphere, radiating engineering mastery. With just a few moments, Starship 5-2 hit max Q, the greatest aerodynamic pressure. The whole shape was sustained at its breaking point for a small, nail-biting moment at T+230. Booster return. The booster returned like any rocket. Unlike conventional rockets, the booster does not encounter the lonely sea, but made a controlled descent back to the launch facility. In a feat that seemed ripped from the pages of science fiction, the booster executed a flawless boost-back burn. As it approached the launch tower, two massive mechanical arms, fondly nicknamed chopsticks by SpaceX engineers, extended to catch it. Cheers erupted from mission control as the booster nestled gently into place, marking its second successful catch in SpaceX's history. This achievement alone was groundbreaking. Reusability is the holy grail of space travel, and catching the booster rather than letting it crash into the ocean marked a huge step toward cost reduction. Once the booster had been returned safely, attention was turned to the upper stage. At T+300, the rocket performed a hot staging maneuver, in which the upper stage engines lit while still attached to the booster. This new method was supposed to enhance efficiency by having the rocket in the air shorter between stages. The separation was apparently smooth, and the upper stage on its merry way to orbit. Then came trouble. By T+739, things began to go amiss. The upper stage's engines started turning off one after another. At T+817, telemetry indicated it was a disaster. The rocket split apart in the middle of flight, and debris sprayed the ocean. Such incidents SpaceX engineers call RUDs, rapid unscheduled disassemblies. While dramatic, they're a known risk in experimental launches. For SpaceX, every failure is a lesson. Cameras captured fiery plumes and burning debris, a stark reminder of the challenges inherent in pioneering new technologies. In the aftermath, SpaceX's engineers pored over data. Initial analysis of the incident has suggested that possibly one of the new upgrades, a redesigned flaps or increased propellant volume, had caused the mishap. That's how progress happens, Elon Musk tweeted just a few hours after the launch. We test, we learn, we improve. In reality, the iterative approach of development relies on pushing systems to the limit to unearth weaknesses. Although the mission was not without fire, it wasn't a failure either. Liftoff, booster return, and the hot staging maneuver were all successful tests. Every step forward gets SpaceX closer and closer to its ultimate aim, a fully reusable spacecraft that will eventually take humans to Mars and beyond. Next in line for the stars, the development of the next generation of Starship. Engineers are refining their designs, addressing vulnerabilities, and preparing for the next test flight. Every launch gets SpaceX one step closer to making interplanetary travel a reality. It is not just about rockets, but the Starship program embodies a vision that will redefine humanity's place in the universe. The lessons learned from Starship 5's seventh flight will shape the future of exploration and spur dreamers and generations to shoot higher. After the debris was settled and the dust was cleared, one thing was certain. SpaceX will rise again strong and more determined than ever. After all, every great leap forward begins with a few steps back. Failure is just a stepping stone in SpaceX's journey to the stars. The question is, what's next for humanity's most ambitious space project?